Okay, let's see. It says use slope to determine whether the points blank, blank, and blank, A, B, and C are on the same line. Justify your conclusion algebraically. Ooh. Well, I think it's maybe it's intuitive, maybe it's not, but I think that if you have 3 points, one, two, three, those 3 points are not going to be on the same line. And the key is the fact that, like, look, from here to here, that slope is different than that slope. And this slope right here is different than this slope. So if I pick any 2 points, I should get the same slope, right? So if I was to contrast that with points that are clearly or appear to be collinear anyways, what a messy graph. Let me see there. I don't know if that's any better. But if I contrast that with points that appear to be collinear, right? They don't have to be equally spaced, but if this was point A and this is point B and this is point C, this, right, B to C has a slope, A to B has a slope, and A to C has a slope, and the slope for all of those should be the same. So if we've got the same slope for all of them, they should be collinear. And then it says justify your conclusion algebraically. And to me, I'm thinking I might want to find the equation of the line that goes through two of them, and just to verify then that the third point is on that same line. So let's go ahead and start and remind ourselves what slope is. And I'm going to put these numbers in a data table. I'm going to go -2. Let me do them in. I'll do them in order with my x value. So -5, 7, and I've got a -2 and a 6, and then I've got a 3 and a 5. So this -5, 7 is point C. The -2, 6 is point B, and the 3, 5 is point A. So those are my 3 points. And if I remind myself that I'm looking at, these are the y's, these are the x's, I'm looking at how much y changes and dividing that by how much x changes to find my slopes. So um, if I wanted to find the slope for A and B, I could say, I guess I could go 5 minus 6 on the numerator, and I could go 3 minus 2 in the bottom. So I think you see what I'm doing there. This is how much y change. So 5 minus 6 is the y change, and I'm going 3 minus -2. So 5 minus 6 is a -1, and 3 minus -2 is 5. So I've got the slope as -1/5 for those 2 points. I'm going to do the same thing for C and B. So for C and B, I'm going to go 6 minus 7, right? 6 minus 7, and I'm going to go -2 minus -5. So I've got, again, I'm just following this pattern here. I'm looking at y change. So 6 minus 7, 6 minus 7 is my change in y, and -2 minus -5 is my change in x. 6 minus 7 is a -1, and -2 minus -5 is, uh-oh, -2 minus -5. Uh-oh. -2 minus -5. That's just 3, isn't it? So I don't think these are collinear. Right? That's where I'm sitting right now. I don't know why I need to go further, but I guess I will go ahead and look at I'm going to find this. That's interesting. Hmm. So that was the slope for points C and B, and this was the slope for points A and B. Let's go ahead and just find the slope for points C and A. Right, so I'm going to do this slope here for C and A and see what that is, just out of curiosity. So for C and A, that would be 5 minus 7 is how much 5 minus 7 is how much y changed, and then I'm going to go 3 minus -5. That's how much x changed. So in my numerator, 5 minus 7 is going to be a -2, and 3 minus -5, 3 minus -5 is well, that's 8, isn't it? So guess what? This is a different thing altogether. This is -1/4. So obviously any 2 points are going to be on the same line. Duh, right? Because through any 2 points there's one line. But these 3 points are not collinear. So that's me just saying they're not on the same line. So I want to justify that algebraically, and I'm going to do that by coming up with the equation of one of the lines and then plugging in that third one and saying, hey, look at this. They're not the same. So to do that, um, there's a lot of ways we could do that, right? There's a lot of ways, but we're here, and I know the slope of AB already, right? This is the slope of line AB. It was negative 1/5. So I'm going to take that slope and I'm going to plug in point A to it to figure out what the y-intercept would be. So I would write, so I'm thinking y equals mx plus b. I know that the slope for line AB is negative 1/5. So I'm going to put a negative 1/5 here. And then I'm going to put an x value of 3. And I'm going to put a y value of 5. Oh, I can't catch a break. I'm getting these fractions. So this equation becomes 5 is equal to negative 3/5 plus b. So I'm going to add 3/5 to both sides. So 5 plus 3/5 is what b is. If I express 5 as fifths, that would be 25 fifths plus 3/5, which would be 28 fifths. That's b. So the equation of line AB is y equals negative 1/5 x plus 28 fifths. Now, I know for a fact if I put in 3, that's going to give me 5, right? I'm just that arrogant, but I am grabbing a calculator and checking it. So I'm going to go, here's negative 1 divided by 5. That's negative 1/5 times 3, then a plus 28 divided by 5. So yes, it did. So for this equation, when I plugged in x was 3, this equation clearly gave me that y was the number 5. So I know that that one worked. So the other point that should work for is it should work for point B. So negative 2 should give me 6, right? So if I put in negative 2 into this equation, right? What do you mean? I'm going to put a negative 2 right here. It should give me 6. So let me try that. So I'm just going negative 1 divided by 5, all right? And then I'm going to go times negative 2, and then plus 28 divided by 5, plus 28 divided by 5 should give me, oh, I messed it up. Let's see. Negative 1 divided by 5 times the number negative 2, right? Clearly that's positive 2/5, right? And then that plus 28 divided by 5, it gives me 6. Okay. So you can see that both of these points work in this equation. It's all happiness, right? Now, here comes the point that's not collinear with those two, and it's C, which is negative 5, 7. So I'm sure that if I put the number negative 5 in here, I am not going to get 7. I'm not going to get 7. If I do, then I've made a mistake somewhere else, but I don't think so. So let's go negative 1 divided by 5. Clearly that's negative 1/5 times negative 5. That's just going to be, yay, the number 1. And then the number 1 plus 28 divided by 5. Guess what that is? It's not 7. It's 6.6, right? So that's kind of a fun review of a lot of things from the beginning of the year, right? We know that these are not collinear because any 2 points selected from those 3 points would have to have the same slope. They were all different slopes. And also, if you generate the equation for any 2 points, if that third point satisfied the equation, so if I make the equation for points A and B, and that equation worked for C, right? Then they would be collinear. But it didn't work for C, right? When I put in -5, I didn't get 7, I got 6.6. So that's question 30. 30, how much fun? 32.